So I promise you today that we're going to go over the preliminary geometry and vocabulary stuff that we need for working with trig. Now most people would assume that when I mention we're going to go over preliminaries of trig that I'm talking about triangles. I am not. Trig is not based on triangles. Trig is applied to triangles. But trig is actually based on circles. So to understand trig, we first must spend a few days dealing with circles. And by a few days, I mean today and maybe 2 or 3 days next week. And then, yes, you will be facing your unit test before we move on to the formal trig unit. So anyway, in a circle, there are some features that we're familiar with. Of course, one of them is center to the outside. That is the radius. Very good. There's also one that looks like this that connects, it's a line segment that connects any 2 points on the circle. Anybody know what that's called? That's called the chord. The segment is the piece between that chord and the outside edge of the circle that's cut off. That would be the yellow part, there would be the segment. A chord that happens to pass through the center of the circle is called a diameter, which brings us to our first mathematical relationship. The diameter and the radius are related how? The diameter is twice the radius. Take 2 of those radii and put them back to back, it would form a diameter. We also have what we just formed right here. This little pi wedge is called a sector. A piece of course, the distance all the way around a circle is called what? Circumference. So we can give it a second form. The circumference of a circle is found as pi, where pi is that constant for a circle, 3.14159, blah, 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 times diameter, or sometimes listed as 2 times pi times the radius, or 2 times the radius times pi, since the diameter is just 2 times the radius. Anybody remember the area formula for area of a circle? Yeah, pi times radius squared. Very good. So the sector that we saw here, the area of a this is for the whole circle. The area of a sector, if you recall, was what? The area of the whole circle times, we use this symbol here, theta, for an angle over 360 degrees. Well, what is that angle? What is theta? Well, theta is this angle right here. That is what is called a central angle. That sector, or what portion of the that sector cuts out a portion of the circumference from here to here. That section is called an arc. The arc length is the circumference of the circle times that central angle over 360. Because again, it's just a fraction of the whole whole circumference. Little hamster isn't staying on the wheel real well today, sorry. Any questions so far? So we have a central angle there. We also have something called an inscribed angle, like this. This angle here would be called an inscribed angle. There's a relationship between that inscribed angle and this central angle if they cut the same arc. The inscribed angle is going to be half of the central angle. Now, normally what we do is we describe this arc out here. And we describe that arc in terms of degrees, and we just match it up with its central angle. So what do I mean by that? Let's say this is an 80-degree angle. we would describe this out here as being an 80-degree arc. What would this angle, pretend that lands on the, that's inscribed. What's this angle here going to be then? 40, very good. What would this angle here be? 40. Very good. What would this angle here be? 40. You're noticing a pattern developing here. Yes, those all end up being 40. So outside of angles, other features of the circle. We had that chord, but if we extend that chord so it keeps going through the circle, we create something called a secant. A secant slices through the circle. A line that touches the circle but never cuts into it, like that, is called a tangent. Now, one of the things you'll learn about this tangent is if I draw a radius of the circle out to that point where that line is tangent, it'll form a right angle with that line, always. Now, if you're dealing with round features, it's a very important thing, especially using a V block or something to hold things in place. It gives you all your dimensions and stuff. But one that's a little bit lesser known, a whole lot lesser known. Let's go back to our diameter here. I want to put a horizontal diameter across here. A horizontal diameter across a circle like that is sometimes referred to as a reference diameter. We talked a little bit before when we first talked about angles, about the whole idea of, bless you, of navigation being kind of the basis of angles and angular measurement. Well, in going back to the navigational sense, the reference diameter here is your east to west direction on the map. They used to use that as their reference point because east to west was kind of considered the standard travel, and north and south was off of the main line. If you looked at land surveying and stuff like that, there's something called an azimuth, which defines dimensions off of some sort of reference line. If we pick a point on this circle, another term that was used in surveying is the distance from that point to the reference line, or to the reference diameter. And distance is always measured at a right angle, or what we call perpendicular. That is called, the length of that is called the sine. So the distance of a point to a diameter is a sine. Any questions? Okay. Tangent is a line that just touches, doesn't penetrate. So for now, we're going to start looking at some dimensions based off of this stuff. Let's say we have, well, let's just do this. Let's say we have a circle here. This is 120 degrees central angle. And this is an 8-inch radius. Watch the two things. One, find the area of that sector. Two, find the arc length. See if you can do them quick. I'll pause for a second. So let's take a look. What did you guys get for the area? 6702 first inches squared. Sound right? What'd you get for arc length? You didn't get the arc length yet? Okay, go ahead. I'll pause for a second. 67.02. So 16 point what? 76 inches. Perfect. Okay, 755. Yeah, 76 is close enough. Like I said, it makes a difference whether you use the pi key or whether you use 3.14. A test or quiz, I'll have both answers done. So now here, what if I were to tell you that this chord across here is 13.86 inches? Let's say I draw a chord across here, and I tell you this one is 13.86 inches. Can you tell me what this arc length here has to be? Perfect, 16.76. What if I make an angle here, and that this angle is 60 degrees? Can you tell me what this arc length has to be? .38. Very good. It's half the angle has to be half the arc. How about the area of this? Half of that, 33.51 inches squared. Very good. If I were to cut this chord in half and make it, 6.93 inches, what do you think that does to this arc length? Half, 8.38 again. The ratio of the angles is the same as the ratio of the arc lengths. Same with the chords. Equal chords have equal arcs. If you cut them in half, it cuts the arcs in half. And change it. The ratios will be the same. So you don't have to do a lot of recalculation once you've done one thing on a circle. Let's see, what are some other things you have to do? So you have tangents here, right? They're going to be perpendicular or right angle to the radius. But the other thing that will happen is the distance from that point of tangency out to where two tangents intersect, that's going to be the same on both tangents. So if you know one of those lengths, let's say I tell you that this is 12 feet, you know this one has to be 12 feet. Because of that, it gives us a lot of important consequences. One, if I connect this to this, it takes this angle out here and it cuts it in half, cuts it into two equal angles. Also, if I had to make a chord across here, this is an isosceles triangle because the radii are always equal, right? If it cuts this angle in half, it cuts this angle in half, which means it forms a right angle to that chord. And also, of course, it cuts that chord in half. So those tangents are a very important feature of any triangle, of any circle. If you're dealing with a round piece, for example, let's say you have a round piece, you're going to put it in a V block to work on it. Pretend that looks round. Let's say you just want to put a flat side on it. So you're going to put it in a V block, and then you're going to run it through the CNC machine just to mill that off flat. Well, your dimensions here now, if you know your radius, you're going to be able to know that the radius is going to be perpendicular to that. If you know this angle down here, let's say you know that this is a 60-degree angle down here. Well, then you can cut this in half and get a 30-degree angle, and you'll be able then from this side to find this distance, to know how high that's up, to know what height to set the mill, to mill it off, and all that fun stuff. These are calculations, and we're not going to do the calculations today. I'm just showing you because these are calculations we're going to get into as we get into the trig. With that, I'm thinking, the last thing we need to talk about, this is something I normally would have covered in first semester, but I want to make sure you have it since you weren't with me first semester. You have a case like this. Two chords that intersect. Let's say this is 4 inches and this is 9 inches here. So each chord's been cut into two pieces. So that's 3 inches. We can figure out what this piece is going to be. Because if we have two chords that intersect each other, the pieces that it's cut into have a constant product. What that's saying is, if I call this x, this 4 times 9 has to equal 3 times x. So 4 times 9 is 36. Dividing by 3, 12 has to equal x. This has to be 12. This is a very useful tool for you guys. Let's say that you have somebody who wants let's say from a kitchen into a dining room, they want an archway framed in. That archway is a sector or an arc of a circle. Let's say our doorway here is 60 inches wide, 5 feet wide. And they want this to be 15 inches tall. To lay that out, what you're going to do is you're going to cut pieces of plywood or whatever to make that arch and put them together and probably brace them in between with 2x4s or whatever material cut to fit in the space, probably 2.5 instead of 2, or instead of 3.5, but you know what I mean. So anyway, we need to figure out what is the radius of that circle, because most likely the way you're going to lay that out is you're going to pin that piece of plywood down to a surface, and you're going to come over here somewhere and anchor a string, and you're going to use that string to pull the arc of the circle. See what I'm saying? Anchor the string and use a pencil on the end of the string. Easiest way to draw a circle in construction. So we need to know what the radius of that circle is so that we can draw that arc. Well, this is going to be half of the 60. Same with this. It'll be 30 and 30. So if we look at the rest of our circle, boy, that drew well. We know that 30 times 30 has to equal 15 times x, which tells us that x equals 60 inches. So that's from here all the way down to the other side of the circle is 60 inches. What that tells us then is the diameter of our circle is how much? Well, 60 plus the 15. So we have a 75-inch diameter and a radius of 37.5 inches. Make sense? Kind of? So that saying is you would measure in here 30 inches from the end, and you would measure down, 37.5 minus 15, you'd measure down 22.5 inches. That's where the center of your circle would be. Then you do that 37.5 inch arc, radius arc. Again, those are things we'll do more of. Andrew's got that sad look over there, like he just wants to go home. So, what's that? Did this again? 30 times 30 is 900. Yep. Divide by 15 is 60. That gives you from here all the way to the other side of the circle. Add the 15 to get the diameter. Yep. Yep. Here, let's do an example of that. Those are actually kind of neat problems. Let's say you're installing a window. It's a 48-inch wide window. There's going to be an arc going in over the top of it. It's 8 inches tall. So we want to know what is the radius of the circle that would contain that arc. So now this dimension x is going to be the first dimension we find. Going from the top of the window to the bottom of the circle. How do we find x? So 48 gets split into 24 and 24, right? So 24 times 24 equals 8 times x, which gives us that x is 72. Correct? So the diameter is 80, good. Radius, 40. So again, if you were to cut this out of a piece of plywood, you would pin your piece of plywood down to the floor. You'd measure in 1.5 inches or 3 inches, depending on what you wanted it, for cripples underneath it for support. And from there, you would measure 24 inches over, and then back this way, not 40. If you want to go 8 inches up, so it'd actually be from here to here, it'd only be 32. 32 inches here. So this is 24. Then you'd come back from here, you would measure 40 just to make sure it matched up. Does that make sense? It's got to form a right triangle. The other way you could do it, the way I usually do it, because it's easier for me, is I come in, I make my mark here, then I would measure my 48 inches, I'd find the other side of the window. And now I just have someone hold the string here and go 40 inches and strike an arc. Have someone hold it here, go 40 inches and strike an arc, and where they cross has to be the center of the circle. And then I measure out here just to make sure it's 32, just to make sure I'm okay. Then you just reverse it. You have someone hold the string here, and you can mark out your arc of the circle, cut it however tall you want it. Then you've got a pattern to cut off of. You only need to do it once, of course. Yeah, so what's that? Yeah, so what you do is you're going to put a cripple here, and your studs up, cripple, studs up. What that piece of plywood would do is it would sit above this, like this. Then you'd frame in between it with pieces of wood you cut the right thickness for your wall, just to reinforce it. Then your header, of course, would go above that. But I usually put blocks in. This would be over a window, yep. The one I did up above is like an archway between rooms. It works the same way. Yep. Yeah, this is going to be a window with an arch, an 8-inch arch above it. This one up here is just like an trying to cover the hole? No. We're making sure our header leaves the space for that arch in. Oh, no. Okay. In your books, page 533. Exercise 25-1 is just vocabulary. If you want to look at those, make sure you understand 1 through 4. Page 537 through 539, similar thing. Exercise 25-4, 1 through 3, and 5 through 15. Make sure you know those vocabulary terms. And then the next set is actually just seeing things that are equal and seeing relationships. Page 542 through 544. Exercise 25-7, 1 through 12. And page 546 through 548. Exercise 25-10, 1 through 8. It appears as though the test, probably Wednesday of next week, possibly Tuesday. Most likely Wednesday, though. You bet. Have a good weekend. Stay out of trouble. Don't do anything I wouldn't do. If you do get in trouble, let me know. I've still got the rug and the shovel in the back of my car. I'll cover it up. I think we should have ended the recording before I